7th grade 1.5, starting on page 25 in your book. We have some key vocabulary up in the left margin of your book right there. So if you would look with me, we have equation. So here we can find my board turned off. Hold on a second. Let me turn on our vocabulary equation. We have maybe let me put my board on here. There we go. So we go. There we go. There it is. Equation. An equation. I'm just going to give an example to start with. X plus 5 equals 10. An equation is a sentence formed by setting two expressions equal to each other. So it has an equal sign in it right there. And I remember equation because equal is spelled E-Q-U-A-L. And look over here at equation. What does it start with? E-Q-U-A, same thing. So that helps me remember equation have equal signs. A solution is the number that makes it true, the number. So in this case right here, the solution would be 5. That's the number that made it true. And then the last one, which is solving an equation. Solving an equation is the process that it takes for you to get 5 as that answer. Did you use mental math? Did you use some sort of algebra? How did you solve for X? Did you just know your facts? So we'll be coming up with all sorts of different strategies in solving equations. And solving it is basically how you get the answer. Okay, and in our case we used, that N is a little crazy, mental, that's mental math. Well, that doesn't look like mental, does it? Oh, well, that's what it is. Alright, so let's go to the next slide. Let's go to the first example and see what we got happening right here. So checking possible solutions. Tell whether the value of the variable is a solution of n plus 5 equals 14. So we put in n. For n we're going to put in a 9. So 9 plus 5 is 14. Is it? If it is, you say yes, it's a solution. If it's not, you say no. So in that case, yes, a 9 is a solution to that equation. So they're solving it here. They're substituting, doing exactly what we did. And the question mark, is it equal? Can you get it? Yes, it is. So the next one, we're still on example 1. This is B. Tell whether the value of the variable is a solution, and this is on the bottom of page 25. So we put in 7 for n, so 7 plus 5 equals 14. Well, 7 plus 5 is 12, and 12 does not equal 14. If you put a line through it, the equal sign, it means does not. So we would say no. No solution. No is fine, but I'm just trying to practice writing with my pen. So let's see what happens. They wrote the equation, which is what we did. They substituted 7 in, which is what we did. They got 12 does not equal 14, so therefore 7 is not the solution. Okay, example number 2. Solving this equation, and I said, we're using mental math, but one of the ways to solve an equation is to ask the question in your mind. So you start with an equation, so let's check out this first one. You start with the equation 9 plus x equals 12. So the question you're thinking to yourself is 9 plus what is 12? So their question is 9 plus what number equals 12? The solution, well, 3. If you add 3 to 9, you get 12. And you check your work, 9 plus 3 is 12. So if sometimes you pose it as a question, sometimes they're obvious, but if you're not sure, you can ask it as a question to help you solve it. So this question would be, what number minus 5 is 10, or what number, if you take 5 away from what number, would you get 10? See how they did it? What number minus 5 equals 10? 15, and what is 15 minus 5? It's 10, so that one works. So C, 4 times what number is 20? Remember 4t, when you have written like this, that means to multiply. 4 times what number is 20? So let's see how they pose the question. 4 times what number is 20? They did. And 4 times 5 is 20. And you check it, and it works. M divided by 3 equals 12. What number divided by 3 equals 12? 36. If you split 36 up into 3 equal groups, you'd have 12 in each group. And that one works out. So the guided practice, tell whether the value of the variable is a solution of the equation. So they kind of run these together. It's kind of right here. They want to know if you put x in right here. So 3 times what number is 12? Well, 3 times 4. Is that 12? Yes. So we would say yes, it is a solution. Okay, number 2. 7 equals 13 minus n, and n equals 5. So we put that 5 in right here. So 13 minus 5, is that 7? You know what? 13 minus 5 is 8. So 8 does not equal 7, so we would say in that case, number 2, that the answer is no. Number 3, 6 divided by what number is 3? So we put 2 in. They tell us what that number is, so we put 2 in right there. 6 divided by 2 equals 3, and you know what? It is. Yes. Divide something by 2, you cut in half, and half of 6 is 3. Solve the equation using mental math, and by doing it, I'm going to pose that question again, just like we did in the example. It was example number 2. What number, right here, what number times 7 equals 35? So x equals 5. 5 times 7 is 35. What number minus 6 is 15? What number, if you take 6 away from it, will you get 15? And I think that's 21 minus 6 is 15, and it is. Okay, there's our check. You can do 21 minus 6, you get 15. 12 plus what number is 32? That one's pretty easy. 12 plus 20. So A equals 20. I'm just going to write that. A equals 20. Over here I'm going to write N equals 21. 24 divided by n equals 6. So what number goes into 24 6 times? And in division, I think multiplying. You know, if these two numbers multiply to get this number, and I know 6 times 4 is 24. So 24 divided by 4 is 6. So n equals 4. You know, a lot of this is just basic facts, just knowing your basic facts and putting numbers in the right place. Okay, before we do example 3, I want you guys to look on page 26 at the bottom of the page where it says distance problems. If you could just follow along while I read it. It says some distance problems can be solved using an equation that relates distance, speed, and time. For example, if you stand on a walkway moving at a speed of 2 feet per second for 30 seconds, how can you use the formula below to find the distance you traveled? So the formula is, and they have it in words, the formula is D equals rate times time. D stands for distance, okay? R stands for your rate, that's how fast you're moving. T stands for time, how long you're moving at that rate. So if you remember, I read we're going 2 feet per second for 30 seconds. Okay, how far are you going to be after that? Well, 2 feet every second for 30 seconds would just be 2 times 30, which would be 60 feet. You would be 60 feet if you go at that rate. Okay, so distance equals rate times time. That's a formula that, make sure you're writing that in your notes, and you're writing distance and rate and time. That's a formula that's commonly used in algebra and in math. You know, we travel miles per hour. That's your rate. You can go to Sterling 65 miles per hour. Or you might say, if I travel for 65 miles per hour for 8 hours, how far will I be? You know, without stopping, maybe. There's all sorts of things you can do with that. So that's what example 3 does. It has a situation where it involves this formula. So let's read example 3, which in your book is at the top of page 27. A homing pigeon is a bird trained to fly back to its home. Homing pigeons can fly at a speed of about 50 miles per hour. How long would it take a homing pigeon to fly 300 miles? So we have our formula right here. Let's put in what we know. Okay, we have 3 numbers here, and in this case we have 50 miles per hour. Anytime you see that per hour, that's the rate. So the 50 is going to go right there. It says how long, so there's some missing time, so we don't know, times t, and you want a total of 300 miles. So again, we have an equation, 50 times what number equals 300? Well, let's just think 5 times 6 is 30, so 50 times 6 would be 300. Let's check that out. Okay, so that homing pigeon, it would take 6 hours for it to fly 300 miles. And we just substituted the numbers we knew into the formula. You know, it didn't really say that 300 was distance, but you knew that's how far it traveled, so that's your distance. 50 miles per hour, again, rate, look for those per, that word for the per, and then the missing part was the time. And then we just used mental math to help solve that equation. So let's see what the next slide has for us. Oh, let's see how they solved it. They wrote the distance formula. They substituted in the values they knew, the 300 and the 50. And again, there's the mental math. So it would take a homing pigeon about 6 hours to fly 300 miles. So let's check out number 8. A car travels on a highway at a constant speed. In 2 hours, the car travels 100 miles. At what speed is the car traveling? And speed is another word for rate. How fast was it going? So let's write the formula. Distance equals rate times time. The car traveled 100 miles. That's the total distance. What speed? We don't know the rate, so we're going to put R times. They last for 2 hours. So for 2 hours, that car had to be going, because 2 times 50 is 100, that car had to be going 50 miles per hour. All right? I don't know many people who go 50 miles per hour anymore, at least on the highway. Probably shouldn't be going 50 miles an hour down Main Street. So let's see if I got that one right. 50 miles per hour, and I even labeled it MPH. That stands miles per hour. All right, so there's some equations and some mental math. Have fun with the assignment, and we'll see you next time. Bye.